Okay, guys, today we're going to look at weighted average problems and mixture problems. Before you get too caught up in all of the dialogue on these, I want you to, go ahead and read through the whole problem and build this table right now before we start. So go ahead and draw this table somewhere in your notes. Label it banana chips, strawberries, fruit mixture, number of units, price per unit, and total price. Now, I'm going to read through, go ahead and pause right now, make this table, and then start it back up. I'm going to go ahead and read through the whole problem to start with, and then I'm going to pick it apart because it's a lot. So, a fruit company sells dried fruit mixture for $5 per pound. To make the mixture, the banana chips that cost $2.49 per pound are blended with the dried strawberries that cost $7.95 per pound. How many pounds of dried strawberries should be added to 3 pounds of banana chips to make the dried fruit mixture? All right, that sounds like a lot, but it's really not that bad. So let's just start by filling in the information that we know and highlighting some information. It says a fruit company sells dried fruit mixture for $5 per pound. So I'm going to go ahead and pick out some information here. Let's go. The dried fruit is $5 per pound. Okay. Right there. Now, and if you look at your table here, it has number of units, price per unit, and total price. Well, we're looking at price here. Price per unit of the dried fruit mixture is $5 per pound. To make the mixture, banana chips that cost $2.49 a pound. So let's talk about banana chips that cost $2.49 per pound. Where should that be? Well, I find my banana chips over here. Price per unit, $2.49 per pound. Blended with dried strawberries that cost $7.95 a pound, I think it says. Excuse me. Strawberries that cost 7.95 per pound. So I'm going to write that where it goes. Well, price per unit, $7.95. Okay. How many pounds of dried strawberries should be added to 3 pounds? So we've got another thing there. Highlight that. We've got 3 pounds of banana chips right there. Okay, so where does that go? It's not a price, obviously. It's a unit. So we've got banana chips cost $3, and they already have the pounds up there for you. All right, so this is the information they give us. Now we've got to figure out the rest of the table. So we don't know. We're trying to find out dried strawberries. So we're going to let X equal the dried strawberries. So I'm going to just put X right there because we don't know how many dried strawberries we need. That's what we got to find out. Now the fruit mixture is going to be the banana chips, 3, plus the strawberries, X, and that's going to give us our fruit mixture. Okay, so now we go the other way. We go horizontally, and we have the number of banana chips at $3. Okay, price per unit $2.49. So 3 times $2.49 is $7.47 for 3 pounds of banana chips. Same thing with dried strawberries. We have X times $7.95 per pound, so we have $7.95 times X. And then the fruit mixture, we have number of units times price per unit. Number of units is 3 plus X times $5 per pound, and that gives us a fruit mixture. So now we have this variable we can solve for, okay? So now if we add banana chips and dried strawberries, that should equal the fruit mixture. So if you look down here, we're just going to take this right here, we're going to add that plus that, and that's going to give us the 3x plus 5, or 3 plus x times 5. So let's just go ahead and write this out algebraically. We have $7.47 plus, that's the bananas, $7.95 times the strawberries, right? That's going to equal, I'm going to switch this around a little bit, 5 times x plus 3. Okay, now, first thing we need to do here is distribute, okay? So I'm going to take that and that to there. Not going to do anything to this left side for right now. $7.47 plus $7.95 x equals 5x plus 15. Now we've got the whole goal here is to get all the variables on one side and all the numbers on the other. I'm going to keep everything positive if I can. So I'm going to go negative $7.47 or subtract that, and that's going to cancel those. I'm going to go, I should do it this way. I'm going to go like this, and I'm going to subtract 747, I believe it was. Okay. Do a little longhand math. We've got a 3, 5, $7.53 left on that side. So let's just rewrite this and make it look a little bit better. Okay. So on the left side, we're left with $7.95 x equals 5x plus $7.53. Subtract 5x from both sides. $5x. And that's going to leave me with $2.95. Or excuse me, 295x equals $7.53. We're getting down here now where we can do some isolating. We're going to divide that by $2.95. Whatever we do to the left, we have to do to the right. Okay. And then I'm going to get my calculator, 753 divided by 295. So I'm going to get out my calculator, $7.53 divided by $2.95. It's going to leave me with about 2.6, 2.55. We'll call it 2.6. So x is going to be about 2.6. And remember what x was strawberries, right? So we need about 2.6 pounds of dried strawberries with the 3 pounds of banana mixture to make a $5 per pound mixture. Okay? So pause that right now. Make sure you have, make sure you kind of go back through it. If you have any questions, stop me. Okay, here's another example of a mixture problem or a weighted average problem. It says Kayla wants to obtain a milk mixture that is 2% butterfat. She has 8 cups of 1% butterfat milk and has some amount of the 4% butterfat milk. So that's going to be our variable. How much of the 4% butterfat milk should be mixed with the 8 cups of the 1% butterfat milk to obtain the 2% butterfat milk? Okay, that sounds like a lot. Let's just start here. Let's start filling in where we want. Okay, she wants to obtain a milk mixture that is 2% butterfat, which is that bottom piece down there. Okay, so she has 8 cups of the 1%. So I'm going to go ahead and put my 8 cups right here. She has 8 cups of buttermilk, or of the 1% buttermilk, and some amount of the 4% buttermilk. We'll call that, I don't know, W. You can use any variable you want. Okay, so obviously if I have 8 cups of 1% buttermilk plus W cups of the 4% butterfat milk, that's going to give me my 2% butterfat. Now on this right-hand column, amount of butterfat, you have to know how percentages work a little bit, okay? Because if I have the, what is 1%? Well, 0.01 is 1%, and I'm going to multiply that times 8%, right? Or I mean 8 cups, excuse me. And then I'm going to have a 4% butterfat, so I'm going to have 0.04. That's the percent times number of cups of 4%. And then here we need a 2% butterfat milk, so we're going to go 0.02% butterfat times 8 plus W. That's going to give us our mixture. Now let's add these things up and see and solve for W. All right, so 0.01 times 8 is, well, you can do the math on that, right? If you want to use a calculator, 0.01% times 8 cups, well, that's 0.08. That makes sense. So we have 0.08 plus 0.04W, which is our 4% butterfat milk, and that's going to equal our 2% butterfat milk, which is 0.02 times 8 plus W. Okay? So if we do the math on that, let's distribute. I have to distribute this across 2% times 8 and 2% times W. Not going to do anything for the left side. 0.08 plus 0.04W. That's going to give me, well, that's 0.16 plus 0.02W. Okay, because 0.02 times 8 is 0.16. Okay, now let's start doing some math here. Let's see. How do we want to do this? Let's keep it positive. Okay, so let's subtract on this side to cancel that. Whatever I do there, 0.08 I have to do there. And that's going to give me 0.08 plus 0.02W on that side. And over here I'm going to have left 0.04W. Okay, so let's rewrite that, clean it up a little bit, make it look a little better. 0.04W equals 0.08 plus 0.02W. Now the whole goal again is to get all the variables on one side and all the numbers on the other. So I'm going to take a negative, or I'm going to subtract 0.02W from that side. That's going to cancel those. 0.02W on that side. Okay, that's going to give me 0.02W on that side equals 0.08 on that side. Then if I subtract, or excuse me, divide to get W by itself, 0.02 is going to cancel those. 0.02, 8 divided by 2 is 4, so if you do it on your calculator, don't forget the decimal places. You're going to go 0.08 divided by 0.02. Oh, sorry. Hang on here a minute. Get my calculator, or my pointer. I'm drawing all over my calculator. Okay. Let's go 0.08 divided by 0.08 divided by 0.02 should give me 4 cups. Should be 4 cups right there. So I'm going to need about 4 cups of the if you look back up here, I'm going to need 4 cups of the 4% butterfat milk to make a 2% mixture. So W is going to equal 4 cups. If you plug that back in, it does work. So up here, you're going to need 8 cups of 1% butterfat milk, 4 cups of 4% butterfat milk to make a 2% butterfat mixture. Okay, guys, now we're going to look at a rate problem. And there's a formula that you need to probably memorize for the SAT and some other things. It says commute. Jean drove to work in 1/2 hour and drove home in 1 hour. So it took her 1/2 hour to get to work and 1 hour to get home. If it is 40 miles from her house to her work, what's her average speed for the round trip? Now, you can't just add these up and divide them by 2 because there's different speeds. So the formula that you need to know, and write this in your notes, is distance equals rate times time. So D is the distance, R is the rate, and T is the time it takes to get somewhere. So what is the average speed? Now, speed talks about rate. So in our last lesson, we solved for variables. So this right here, I need to figure out how to isolate that R. So what I'm going to do is I'm going to solve this for R so I can at least start this process. So in order to solve this for R, I'm going to have to divide by T and divide by T. That's going to give me these are going to cancel, right? And I'm going to have my rate equals distance over time. So there, at least I can get started. So let's just first start with she drove to work took her half an hour to get to work, and it's 40 miles. So I'm going to start right here by going, okay, if it's 40 miles to work, and it took her 1/2, this is going to work. And then over here, let's do returning home. Okay. And then going home, the distance is the same. It's still 40 miles from work, but it took her 1 hour. This is miles, and this is hours. This is miles, and this is hours. So that'll give me her rate of speed. So if you go 40 divided by 1/2, well, she drives pretty fast. She drove 80 miles per hour going to work, and then returning 40 divided by 1, she drove 40 miles per hour coming home. Must have been a lot of traffic, I guess. So there's her rate of speed going to work, and there's her rate of speed returning to work. Now we need to find the average speed, and in order to do that, so we're going to take her back to our equation. Rate equals time over distance, or excuse me, distance over time. So we're going to take her 80 miles per hour times a half an hour, and we're going to add to it her 40 miles on the return trip times 1 hour, and we're going to divide that whole thing by the total time, which it took her 1/2 hour to get there, and it took her an hour to get home. So that's 1 plus 1/2. So if you do the math on that and do some revision, 80 times 1/2 is 40, plus 40 times 1 is just 40. And we're going to divide it by the total time it took her, which is 1.5 hours to go there and come back. And do the math a little bit more. Top's 80 divided by 1 and 1/2. And that gives you, if you do the math on your calculator, about 53.3 miles per hour would be her average speed. If you take her speed going at 80, her speed coming at 40, total time of 1 hour, 1.5 hours, her average speed was about 53.3 miles per hour. Okay, we're going to look at a distance rate times time problem again, a weighted average. It says Eli and Beth are 15.5 miles apart. Eli is going on a bike ride to visit Beth. He rides at 12 miles per hour. At the same time, Beth drives her moped at 30 miles per hour to visit Eli. When will they be 1.5 miles apart? Okay, so here's a picture of it. First of all, they're not going to actually, it's not when they meet, it's when they're going to be 1.5 miles apart. So let's say I think the moped's going to go faster. So when will they, let's just say this distance is 1.5 miles, okay? And this total distance up here is 15.5 miles, okay? So let's look at this table down here. It says Eli is traveling at 12 miles per hour. So his rate is 12 miles per hour right there. The time, we don't know. We'll call it T. We don't know. That's what we're trying to find out, okay? And then if you multiply, so the distance equals rate times time. So if you multiply R and T, this is going to be 12T, 12 times T. Same thing for Beth. Her rate, it says, is 30 miles an hour on the moped, quite a bit faster. We don't know her time to travel that far. And if you multiply 30 times T, you get 30T. Okay, now we can add 12T and 30T, but it's not gonna equal 15.5. It's gonna equal 14, because if you take, remember we need this distance right here subtracted from the total. So if we got 15.5 minus 1.5, we get 14.0 miles. So together they're going to travel 14 miles in different directions, but together they're going to travel 14 miles to get to that 1.5 miles apart. So if we do the math on that, this is going to be 12T plus 30T because they're traveling together. I mean, they're closing the distance together, and that's going to equal 14 miles. And if we solve for t, that'll give us how long it takes, or the time it takes them to travel 14 miles. Okay, so that's going to be 42. Okay, so we have 30t plus 12t is 42t, and that's going to equal 14. Okay, and if we divide each side by 42 on the calculator, 42 divided by 14. Sorry, 14 divided by, that's wrong. 14 divided by 42, that's going to give me 0.33. So we're just going to call that 0.33. Now, let me go back here. T is going to be 0.33. Well, what does 0.33t mean? Well, that's 0.33 of an hour, right? Because we're talking about time. So if I multiply that times 60 minutes in an hour, times that's going to give me 20 minutes. Okay. So if I go back here, the time it's going to take them to be 1.5 miles apart is 20 minutes. If he's traveling at 30 miles an hour, and if he's traveling at, 12 miles an hour, in 20 minutes, they'll be 1.5 minutes apart. Okay, so that's how to do weighted average problems. Go back, review some of those videos before your assignment, and good luck.